Hey there. So another day and the news on another supply chain attack. But if you wonder if you are going to discuss about SolarWinds, then the answer will be a no here. Actually, this supply chain attack was the most least spoken or discussed in the infosec community to what I saw observed in the past few days. The one we are going to discuss in this episode was a supply chain compromise on the Clickstudios Passwordstate. By this time, maybe you are already aware of it, or just wondering when you listen to it to think whether this has been used in your tech stack, I mean, in your enterprise, I am part of or not. Then you should really have a dig into it because this problem is a pretty serious one. Even though the CNC server was taken down within less than 48 hours, I would say, but according to the advisory list from Click Studios, they are expecting a wide number of customer compromises. But in this case, I would say the threat actors were very clever, because they chose to compromise the update package of the password manager password state. If you're being a security analyst, BlueTeamer, or as part of the CERT, I would say a threat intel guy as part of the CERT within your org, or your enterprise is actually using this password manager software, then this episode will be a bit interesting for you. And in one advisory recently, ClickStudios mentioned that more than 29,000 prestigious customers worldwide, and they are assuming that should have potentially impacted a large number of their customer base. But what's with this attack actually? With the update mechanism. That the update mechanism was used to drop a malicious update via the zip file, which terms as the password upgrade.zip, which is a zip file, which contains a rogue DLL, I would say, which they call it moserware.secretsplitter.dll. In fact, the threat actor just added a small component, code component, which they call it a loader component, to the original DLL, and made it a bit rogue. So here we can say that the breach is time bounded, because Click Studios mentioned that the breach was between 20th of April 2021, I mean UTC time, to 22nd. So pretty much it's going to be like less or less 48 hours of breach time, because within those 48 hours the CNC server, the rogue CNC server, which was being used by the threat actors, has been taken down, has been terminated. So if in your organization you did the upgrade of your password manager software within this time zone, within this time frame, I'm very sure, you can be very sure that you are part of this compromise, and it's the right time that you act immediately. So the update mechanism, which we know, is actually dropping a malicious update via the zip file password state underscore upgrader zip, which contains this rogue DLL moserware.secretsplitter.dll. But they name this malware as MOSERPASS with the name given in the DL actually. So what's this actually? This is nothing but a modified version of this original DLL with some malicious code injected into it, and they term this as MOSERPASS malware. So the code is nothing but a small loader was added to the original DLL, which actually tries to download, a malformed second stager from the CNC, and loads it directly into the memory. So according to the Click Studios advisory, that they were not able to track what was loaded in the second stage. In the first advisory, they said because the CNC was taken down, whereas in the latest stage they said that they on purpose they don't want to share the details of the second stager. But they pretty much the advisory they published was very detailed and very good. So what's this MOSERPASS functionality, or the TTPs, we can say? Pretty much, I would say TTP. When we say the word TTPs, it's not a big TTP to relate to the Mithra attack, I would say, because the DLL. The main idea of the DLL is to steal what all the passwords has been inside this password state manager. So we all know that it's the malformed zip file which contains the rogue DLL, which is of size 65 KB, which is something to be noted, because during your incident response time and you're trying to check your file system, if you find the DLL is of the size 65 KB, already you are compromised already. And as I said that this zip file subsequently gets in touch with the bad actor CDN network, which is a CNC, and tries to load that zip file as a dotted assembly in the memory directly in the memory. So the second stage, or whichever it's loaded in the memory, is actually not aware at the stage. Pretty much this MOSERPASS malware, we can say that all your secrets belong to us, but or belong to the threat actor, because the malware exfiltrates almost everything from the password state manager. If you say that it tries to obtain the password state instance password table, I mean the username, the description, what are generic fields you add, the password most importantly, that's what they really require, the computer name, the domain name, the current process, blah blah blah. They try to get everything, even the password instance proxy server address, username and password, everything. They try to exfiltrate as much as they can, and the moment they try to exfiltrate it, they sleep. The DLL sleeps itself every day and again wakes up. So if if you are not even if till now, if you haven't checked that about this upgrade in your org, or you haven't even run those IOCs in your logs to check, it's high time you act. We all act immediately, because this is a pretty serious issue. So let's now look into the quick analysis of this loader component, MOSERPASS DLL. I'm not going to analyze each and every line of the code, because that's not the objective of this podcast. Because the main motive of this podcast for me is to touch the components in the aspect of threat intel, as well as to really understand the functionality behind the malware, but not to go each and every line. And as a BlueTeamer, as a security analyst, what you can do in the defense side as well. So let's quickly decompile this moserware secret splitter DLL. As you know, as we know that it's a .NET compiled one, we can quickly decompile it with dnspy to see not every line of the source code, but to see what's gonna be interest of us. Let us go inside. Let's see. And as it was already told, it seems to be this kind of moserware algebra numerics is the proprietary code of Clickstudios, and whereas this loader component, this kind of loader component, is where the malicious uh, code has been injected into this DLL by the bad guys. So it has two components. You see container and loader. Let's quickly see what is it. And let's see, it should decompile. Okay, let's quickly see what's the loader component here. And the moment you see it has some get is decrypt, get proxy info, and there is also a loader component which is trying to process thread function, etc. So let's see what's there in the loader to decompile. And pretty much you can see the source code that it tries to form, what is it, some create request URI string. So it's trying to form a URI string with some callbacks, and it also tries to put up some TLS, some kind of security kind of encryption, I would say. So the method is get, and a nice hard-coded user agent. Quickly, one advantage to use this kind of one advantage to decompile this malware, to understand, we can quickly retrieve some IOCs. Yes, I can agree with you that those advisories given by this uh, the forensic, the research companies have those IOCs, but still it's also a fun part that we can quickly see that by decompiling this .NET malware in dnspy, we can know this is a quick IOC. We can start correlating this within our logs to see for some indications of compromise. So it's a get request. It forms a get request with an hard-coded user agent, and it makes sure everything is made in an encrypted way. It tries to bring in the security protocol SSL3 and TLS. And what it does, it tries to send it to kind of some proxy. Okay, this kind of if code is trying to call some kind of proxy class with request or proxy, which predominantly should go to get proxy info, and whatever is response it tries to load it in memory. So it's gonna read some call some memory stream, and boom, it writes in memory. So pretty much in few words, we can say that this malicious DL component is gonna connect back to the CNC controlled by the threat actor. It's gonna download an encrypted version of the code, which it will decrypt it, and load it in memory. So the second stage is not known what is it because the CNC has been taken down. So pretty much if we just go right click this get and see analyze to see what's been called, that's a very nice to analyze to see. It's been used in the loader, which is this one, the thread function, and it's been used by boom a lot of classes. Let's see what's been thread function has been used here. So what's this thread function? So thread function is gonna be to wanna get the container URL. It forms the URL, tries to obtain the proxy server, boom boom, and there is if component. See, so if this component is not null, it's gonna call this AES decrypt and contain a decrypt key. So this AES decrypt is actually nothing but this one. So whatever is being fetched from the CNC server, it's gonna call this decrypt packet decrypt function to decrypt with some hard-coded password according to the advisory. But I didn't really decompile it. I mean, to debug it to obtain the hard-coded password, which it sends, and it's gonna load the same in memory, and it's gonna sleep. Which is the most interesting part is that if it sleeps at a regular interval, it's going to wake up again. And if in your enterprise, imagine a situation that every day you try to reset your password, and you also go to sleep, the malware which sleeps wakes up and tries to get this information, those kind of exfiltered data, and it will send back to the CNC server if this DLL is still running, which is very nice. In other words, so let's see what this get proxy info does. So the bread proxy info code tries to obtain the process, the current process it runs, the current domain. Boom, it tries to obtain the current domain as well. And the most important thing, it's the password state. It has a if and a try catch block where it tries to obtain the proxy server name, username, password from the system settings, and it also obtains the property DB connection settings, and it tries to make a nice SQL query where it pretty much reads everything here. You see, proxy server username, proxy password. It tries to read everything here, and it's pretty much your secret is my secret, to be honest. And then it has a method which tries to decrypt the second stager using this AES decrypt, which is nothing but this one. And whatever is been here in the container has been sent to the loader code where it tries to process it within the thread function, because that's what we saw here in the thread function, and it's gonna sleep. And pretty much it tries to use some MD5 crypto service, MD5, the decrypt key thread function, because I think it tries to run as a separate thread, which we can see. Exit locker, it has a thread is being locked for some time, and whatever comes back in the response, it's been loaded in the memory, which is the second stager. And it tries to say do the same thing again and again. If this DLL is active and if the CNC is as well active, every day it tries to wakes up and does the same thing again and again. And I think pretty much that's the quick overall summary of what this malicious DLL is done, the rogue DLL is doing, this moserware malware. But we can quickly run to each segment of the code, walk through each and everything like I did in SolarWinds case, but I chose not to because it's pretty much not too complicated. This one, it's self-understandable. We know what it does, but the issue is a pretty serious one, because this kind of supply chain attacks on the password state manager, it's a password state manager is a software used to store all the password, is a pretty serious one, because the threat actors, they keep on looking, because once this gets leaked, as I said already, they're gonna sell it in the dark web for sure. So on the next stage, yeah, there are going to be, if there is a supply chain incident and there is an advisory, there's going to be IOCs for sure to check, and that's the predominant what to say, the action needs to be done by the security analyst and the BlueTeamer. I mean, the threat intelligence analyst, I would say. But I mean, I don't see much difference in the terms of SOC, but yeah, there can be some differences here and there. Let's not argue that here. Let's not argue that here. and it's time to hunt them down, because if you run those IOCs against your logs, and pretty much if there is a match, in case if your enterprise is using this password state manager, if there is a match, it's high time the incident response team takes a closer look to see um, the nature of the compromise, because it's going to be the window of the time of I mean the window of compromise is going to be only within 48 hours, because the CNC server was already taken down, etc. But during those 48 hours, there can be high risk that the entire data that has been stored on this password state manager, which is your password, username, etc., will already been exfiltered to the threat actor. And there is another way to check the presence of the Rogue Dll, which is directly to check into this inet password state bin directory. And the most important thing you need to note here is to see the file size, which is going to be 65 KB. And pretty much this can be a very quick way to analyze, because you can also use Yara if there is Yara rules already. I think Florian Roth already released a Yara rule for it. If you are going to use a Yara scanner to scan those machines, you can do it. But as a quick win is to do the IOC check, and the second thing is to check directly the presence of this Rogue DLL into this directory and its size. And according to the advisory from this Clickstudios, they say that there is some hotfix being done. You need to install those hotfix, verify things, etc., etc. But for me, the problem is more than applying the hotfix, because if during that 48-hour window the threat actor has exfiltrated the username and password in your organization, there is a big problem, because you need to reset all those uh, passwords of the devices which you have stored here. Maybe I'm not sure how your organization maintains. If you are trying to maintain the password of your web server, which is external facing, blah blah blah, it's high time that needs to be reset immediately. And you really have to check your logs a bit deep to check for anomalies, because uh, you never know what will happen, because if those has been exfiltrated threat actor. And your 13 team should really have a closer look on those forums, dark web forums, for example, XSS or everywhere, somewhere, or Raid forums, I would say, even to see that if it has been shared with some any ransomware gangs, it's been put up in sale, etc., because highly likely those things can be leaked by the threat actor, because they always want to make money. And if they're trying to sell those credentials and the data to some kind of ransomware gang, it's pretty much a disaster. And the other thing I want to specify here is you can download the Rogue DLL directly by specifying the hash in virus total. And the one thing I want to show is the rule set, which has been put up by Florian Roth. Thanks to him, because you can quickly view the rule set here. You can uh, make a Yara scan on the machine to see for those presence of DLL, if that's also a way, I would say. And also the other one I want to say is to check the CNC to see if we can download the original zip package, which is the upgrade password upgrade.zip. But sadly, when I was trying to see that, there have been a lot of URIs during those dates, which is gonna be 24th 20th, I would say 24th 20th it's gonna be. But pretty much I was not able to exactly um, get the compromised package or the second stager which has been loaded. But if someone has it, please do share it with us, so we can see what's been loaded. It's always good to gather more intel on this attackers TTPs. And that's actually a gold mine, because you never know, the same kind of attack might again repeat, because more over the time we have been seeing the same CNCs has been used, the same TTPs have been used, and still we fail to stop the threat actor. And I think that's it, guys, for this episode. It should be, I wanted to be it a bit short one, but also uh, uh, an important one in terms of the supply chain attack. Ciao.